Hello and welcome. My name is Alan, and today we are going to start talking about some of the science principles we need to know. And I figured we'd start off with one of the most important to begin with. That is the scientific method. And just as a starter here, Merriam-Webster.com says the scientific method is a set of principles and procedures for the systematic pursuit of knowledge involving the recognition and formulation of a problem, the collection of data through observation and experiment, and the formulation and testing of a hypothesis. So, yeah. Now, when I was doing research on this, some um, sites listed the scientific method as having four, some five, some six, some even seven. But breaking down, looking at all the sites, the basic idea is you want to state your question or your hypothesis. Um, and of course, a hypothesis, I think it's just like your idea, your theory. Uh, Hypothesis, according to Oxford Languages, says is a supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation. So yeah, it's your theory. It's your you also can be formed based on a question. But yeah, and then from the hypothesis, you want to test and see how things um, happen. After testing, you want to examine the data. So you examine what the tests provided. And then after examining the data, you state a conclusion. Those are the very base parts of the scientific method. Um, then if you look at something like Wikipedia, they have formulation of a question, your hypothesis, prediction, testing, analysis. So yeah. But the idea of the scientific method is that it's the base form on how all scientific experiments should be done. Um, how to test things should be done. Um, Also from Wikipedia, a linearized pragmatic scheme of the 4 points above is sometimes referred to as a guideline for proceeding. And then they post 8 points here. Define a question, gather information and resources, form an explanatory hypothesis, test the hypothesis by performing an experiment and collecting data in a reproducible manner, analyze the data, interpret the data, and draw conclusions that serve as a starting point for a new hypothesis. Publish results, retest. So, yeah, I mean, we're seeing the basic ideas of how the actual scientific method runs. But there's a number of procedures that are added and lifted, but the biggest thing is question or hypothesis, testing, analysis, conclusion. Those are the 4 main points. You can add things within them, but yeah, none of the things that are added are, it's not that they're not important, but sometimes they just go in some of the other categories. Um, but yeah, you want to be able to have the hypothesis or theory or ask a question you want to test. If I do this, what will happen? Uh, does this principle match this? And you often have to do the testings. Um, you make sure laboratory conditions are correct because you don't want um, external variables. But yeah, you do the testing and gather your information based on the analysis, based on the testing itself. Um, and looking at the analysis, at the information, you draw conclusions. Um, and if you feel you need to, you might draw a new hypothesis. Often, these tested hypotheses shall be retested by others. And that's, you may feel that could be insulting, but it's a hugely important part. You mustn't take it as an insult because you want your work to stand up to the testing, the experiments of others. So, yeah, um, don't feel that retesting it is an insult. It's not. It's verifying what you have tested is correct. That the conclusion you came to is the correct conclusion, is what they come to. So, yeah, the scientific method is hugely important especially when it comes to science. So, but yeah, we definitely need to use such a uh, planned model for anything we test like that, for anything we feel needs testing. But yeah, um, now again, there can be added stages. There can be slightly different versions of the scientific method, but like I said, the four are the main things that come with the scientific method. But yeah, um, you definitely want things uh, tested if you come to certain conclusions, or if someone else comes to certain conclusions based on the tests they've made. Everything always needs retesting. There shouldn't be any worry, any fear in doing retesting. But yeah, um, it definitely is one of the foundations of science. Again, referring to Wikipedia here, in a graphic they show at the top of the page, they show in a circle observation question, research topic area, hypotheses, test with experiments, analyze data, report conclusions, and it's in a repeating circle because they have an arrow showing do it again, do it again. And there should always be retests and redos. You want uh, multiple tests to show the same thing. Test it over and over. And if you keep getting the same answer, if you've made sure you have no external variables that could affect the results, then you may have uh, definitely be onto something. Yeah, just wanted to kind of mention it as a beginning point for science. I said I was going to do some science videos, so yeah, I'll go ahead and list the sources in the description below the video. As always, educate thyself, think, read, study, learn. Someone tries to tell you something you have trouble believing, ask them to cite their sources. I'll see you all in the next video. Until then, later.